Hello friends, today we are going to take some gate problems pertaining to plate load test. In the last video we have already explained to you how the plate load test is conducted at the site in order to find out the bearing capacity of the soil mass and also how to find out the bearing capacity of a prototype foundation. We can also find out the settlement based on the ground condition, the settlement of a prototype foundation. So these are the three problems that is taken from the gate examination. These are the problems. Question number 1 that was asked in 2017, and the question is like this. The plate load test was conducted on clayey strata. The strata was clayey in nature by using a plate of 0.3 meter by 0.3 meter. As you know, the size of the plate is going to be 30 centimeter by 30 centimeter, and the ultimate load per unit area of the plate was found to be 180 kilopascal. We need to find out the ultimate bearing capacity of 2 meter wide square footing. So the size of the actual footing is 2 meter by 2 meter. So what would be the bearing capacity of this particular footing? So from plate load test we know what is the ultimate load per unit area, that is the ultimate bearing capacity from plate load test. So if you go to the solution, we can find out the solution. Solution of question 1 will be like this. Here it is given that the ultimate load carrying capacity from the plate load test equal to 180 kilopascal. And very important is what is the properties of the ground. So ground is clay ground. So if it is clay ground, it is independent of the size of the footing. So plate size is already given to you, 0.3 meter by 0.3 meter, and this is the ultimate bearing capacity from the plate load test. And you need to find out the ultimate bearing capacity of a footing. The size of the footing is given to you as 2 meter wide. But because the ultimate bearing capacity of a footing equal to the ultimate bearing capacity of the plate, because it is independent of the size if the ground is cohesive. Therefore, the ultimate bearing capacity of the footing will be 180 kilopascal. Very simple problem. Similarly, we can go to next question number 2 that was asked in gate 2008. A test plate 30 centimeter by 30 centimeter resting on a sand deposit. Now, what is the nature of the ground? That's important. So, question 2. The ground is going to be sandy ground. So, sand deposit. So, it is sand deposit. Satisfied 10 mm. So, the settlement of the plate is going to be 10 mm, and the size of the plate, width of the plate is given to you as 0.3 meter or 30 centimeter. That's given. Under a certain intensity, so loading intensity, under a particular loading intensity, a footing of 150 centimeter by 200 centimeter. So what is the width of the footing? So width of the footing is going to be 150 centimeter. Resting on the same sand deposit and loaded to the same load intensity. So load intensity is not going to change. Settles by. So you will have to find out the settlement of the prototype foundation. Now because it is a sand deposit, the relationship between the settlement of the foundation upon the settlement of the plate must be equal to, here it will be settlement of the foundation is going to be BF into BP plus 30 centimeter divided by BP into BF plus 30 whole square. So this equation will give you, this implies that the settlement of the foundation equal to the settlement of the plate. The settlement of the plate is 10 mm. So it is 10 multiplied by the width of the footing is 150. So 150. And width of the plate is 30 centimeters, so 30 plus 30, 60 divided by, it is width of the plate 30 multiplied by width of the foundation 150 plus 30, that is 180 whole square. So you can cancel it out, simplify it, right, and there is 3 here, so it is going to be pi by 3 whole square, so it becomes 10 into 25 divided by 9, that is 250 divided by 9 millimeter. So if you calculate it, 250 divided by 9 comes out to be 27.77. So this is equal to 27.77 millimeter. So this is the answer of question number 2. Wherever there is a sand deposit, this formula you have to use it in order to get the settlement of any prototype foundation from the data of plate load test. So plate load test data will give you the settlement of the plate, and the size of the prototype foundation is known to you, so you can calculate it this way. Let's go to the next problem now. The last problem that was asked, question number 3, that we will see the solution of that. So that's also quite simple. Let's calculate that. So we have already solved 2 problems. The third one, let us see what is this. This was asked in GATE 2003. In a plate load test conducted on a cohesionless soil. Again, the soil is cohesionless. So here, question 3 solution. Type of soil is very important. It is cohesionless. And 600 mm a square test plate. So size of the plate, width of the plate is given to you. Plate settles by 15 millimeters. So the settlement of the plate SP equal to 15 millimeter. Okay, under load intensity which is given as 0.2 megapascal or 200 kilopascal. all conditions remaining same. So same ground, same intensity of loading, all conditions remaining same, settlement of a 1 meter square footing will be, you will have to find out the settlement of 1 meter square. So width of the footing, prototype footing is 1 meter square footing will be, so it's a very simple problem again. So you need to find out the settlement of this footing. So settlement of the footing upon settlement of the plate must be equal to width of the plate, width of the footing into width of the plate plus 30 divided by width of the plate into width of the footing plus 30 whole square. Using this relationship, already SP is known to us. Width of the footing 1 meter, it is known to us. Width of the plate, it is 60 centimeter, it is known to us. All required informations are given in the questions. Therefore, we can easily find out the settlement of the footing. So settlement of the plate is 15 multiplied by width of the footing is 1 meter. So it will be 100 centimeter, and width of the plate is going to be 30. Width of the plate is 60. So make it 60 centimeter plus 30 divided by width of the plate 60 centimeter. Width of the footing is 100 plus 30 whole square. So if you simplify, you can get the answer. Let's take the calculator and simplify it. So this becomes 15 under bracket. We can simplify it. This is 90. 10, 900. Divided by 130 into 6. So 780. Which is 780 whole square. So if you simplify it, you will get the answer in millimeter. Let's calculate. Is 90 divided by 78 whole square multiplied by 8. So the answer comes out to be 19.97 millimeter, because this is a millimeter. So you will be getting the answer settlement of, therefore the settlement of 1 meter square footing will be settling by approximately 20 millimeter. So approximately it will be 20 millimeter approximately. So like this we can solve all the problems. Thank you very much.